Okay, so this video is going to be only a few minutes and it is intended for the most common mistakes that were made on test number one, the very last problem where you actually had to do some hand calculations. Both problems are actually identical. The drawing is different, but they are identical. You can see it on the top left and top right. And there's absolutely no difference between these problems. Just concentrate on the left hand, for example, and the one that I did for you in class, which is down below it. Absolutely no difference. The only difference is that your A in the problem below is R and B is actually 2R. So yeah, I know that we obviously people may not have realized that, but that's okay. You could have done it from the very fundamentals and gone with the problem. Okay, so let me show you what was the most dramatic issues that even if people did not realize that this is exactly what we did in class, the mistake that they made. So let's go to next video. So a lot of people, not a lot, many people, many people started with theta, and then they realized that, okay, it doesn't matter whether we use x or theta, because that is true. So then they went and looked at the notes. Probably somebody somewhere saw x equal to r theta because of a different problem that we had done. So every time they saw a theta, they replace it with x over r. The problem is that the x for the damper is r theta, but for the spring is 2r theta. So you cannot just recklessly go and say theta equal to x over r and theta dot equal to x dot over r and do it for the spring and the damper. So you have to be very careful. You can't do it like that. The other issue, if you're gonna use x, at some point you need the value of the mass. In other words, you decided that you're going to use the mother of all equation mx double dot plus cx dot plus kx equal to 0. Fine. But the question is, what is the value of m? And they said, okay, I'm told that the JO, I'm given JO, and I know that JO is 1 half mr squared. So let me go ahead and solve for m out of this. The problem is that this formula is for a uniform disk of radius r. We don't have a disk, uniform disk. We have a pulley. So if you're going to find mass of the pulley, you need to have the radius of gyration of the pulley that was not given to you. So you see, it was not possible to convert things to x anyways because you don't have the radius of gyration. Everything must have been done in the theta coordinate, just like I did uh, uh, the review problem for you. Previous slide, the bottom slide, the bottom drawing. Now, the other issue was that you were asked to find the value of c when the system is critically damped. So people realize that critically damped means uh, zeta equal to 1, and zeta is c over 2 root of km. Now, first of all, a bunch of people use k and m down there, but that's an issue. But these have to be effective. But even the thing on the top, that is not the value of the c of the damper. That's the effective uh, damping coefficient. And if you had done it properly, just look at that review problem that we did in class. The C effective is just CR squared. In that problem, it may have been CA squared or CB squared. I can't remember. But anyway, CR squared. So you can't just go ahead and find C out of that top equation and say, here's the value of C. That is not C. That is C times R squared. And then you have to find C out of that expression. Okay, I felt that this was going to help you if you did well in the course, even in this part of the problem, this part of the test, that's great. If you have not done well, then I suggest you look at these and at least learn from your mistakes. Okay, take care.